All right, so in this video, we're going to do the fundamental theorem of calculus being applied to something called the mean value theorem for integrals. Now, hopefully you remember that there was a mean value theorem for derivatives. Now there's one for integrals too. Now, basically what that says is if I have a definite integral like f of x dx from a to b, what that does is it tells me the area under the curve. Now, when I flip over and look at the other side of the mean value theorem, it says that there should exist some x value that makes a rectangle whose area is the same and whose width is the same. So that means that even though I've got this, in this case, parabola from 9 minus x squared from negative 3 to 3, I've got this parabola, I could make a rectangle of some height here that's going to have the exact same area as this parabola, which is kind of a neat fact. Now, here's the thing you got to know, though, is what we're looking for here is we're looking for that x value that's going to make that. Now, in this case, this parabola, there's actually going to be two x values that make it because you notice it's a curve. It's actually, it's not one-to-one. There's going to be two x values here that make the same thing. But remember we're looking for. It's going to have the same width. It's just now going to have a different height, and it's not going to be curved. It's going to be a rectangle. So here's what we're going to do. I'm going to calculate that up there, that definite integral, and I'm going to try to figure out, using the mean value theorem, what c would work for this. So let's see. Definite integral from negative 3 to 3 of 9 minus x squared dx. Now, hopefully you guys are getting used to these definite integrals. So I'm going to kick these exponents up by 1 and divide by the new exponent. So, for instance, this 9 has 0 x's. So I'm going to bump it up 1, so it's 9x to the first. And going to divide by 1 because that's the new exponent. So don't really have to worry about that. On the other hand, I've got that x squared. Well, so that's going to become x to the cubed. And I'm going to divide by the new exponent, which is 3. Now I need to evaluate it from negative 3 to positive 3. So, again, plug in 3, plug in negative 3, subtract them. So 9 times 3 minus 1/3 times 3 cubed. That's the first part. Then I want to subtract 9 times negative 3 minus 1/3 times negative 3 cubed. All right, so I'm going to start working on that in my calculator. So this first part, 9 times 3 is 27. 9 cubed is also going to be 27, but then we're going to multiply it by 1/3. So it should end up being, and I'm just taking a guess off the top of my head, I'm thinking it's going to be somewhere around 18. Let's see what happens. Sure enough, I got 18. Then I'm going to subtract, kind of the same thing over there. So I'm going to instead do negative 3s instead of positive 3s. So 9 times negative 3 is going to make negative 27. That's going to turn into a positive, so that's actually going to turn into negative 18. But remember, we're going to subtract here, so it becomes adding. We get a total of 36. Now, I've got that figured out. So the area under this curve right here is currently 36. Now, I've got that figured out. So here's what I'm going to do next. I'm going to take the width of this interval, which in this case is 6. It's 3 minus negative 3, which is 6. I'm going to take that and I'm going to divide, okay? So 36 divided by 6 is going to give me, of course, everyone knows it, it's 6. Now, that means in order to make a rectangle of the same area, it's going to have a height of 6. So that means if and I'm just going to eyeball it here, 1, 2, 3, 4, 5, 6. If I have a rectangle here that stops at 6, this rectangle and that parabola have exactly the same area. So all I got to do now, and this is my last step, is figure out where the parabola is 6. Now, notice it's probably not going to be a very pretty answer, but I'm going to try to figure it out in just a hot second. I'm going to grab a new marker. So, like I said, my height right now, the height that it needs to be, is 6 because I took the total area and then I divided it by the width of the interval. So, again, I'm going to say 9 minus x squared, and I'm going to set it equal to 6. And that's going to help me find the c value that I'm looking for. So I would subtract the 9 and get negative x squared equals negative 3. Divide by the negative and you get x squared equals positive 3. And then square root it. So you're going to get two answers. Plus or minus the square root of 3. Now, again, these are the possible values for c. So that means, let me repeat one more time. The rectangle is 6 wide, 6 high. In order to find out where that touches, that is -3 here for the x value. And positive square root of 3 for the x value over here. Okay? Hopefully that helps you guys better understand exactly what this mean value theorem says. Remember, there's always going to be a c. There's always going to be some x value that makes it. Hopefully that helps. And if not, ask me any questions.